Alright, so now we're going to solve indefinite. Alright, it's important that it's indefinite integrals because we're going to get to definite integrals later. And then the indefinite part, well, that's the plus c. That's why the plus c is very important. Alright, the plus c means I'm finding not just one indefinite integral, but one antiderivative. I'm finding all possible antiderivatives, the family of antiderivatives. So I know it seems subtle, but that plus c is very, very important. So don't forget to put it on there. Don't lose points because you forget to put on that constant at the end. Again, it's important. That's what makes it the indefinite part. That's what gives me the family of all possible. And again, remember that c represents infinitely many antiderivatives. I can have any number on there from negative infinity to positive infinity. Alright, so don't forget the plus c, family of antiderivatives part. Alright, so the first expression. Alright, so I've got my e term and I've got 3 divided by x. So I'm going to rewrite this. This again would be more of a mental step, and I want to show you what this means because students tend to have trouble with the number divided by x expression. They forget what that means. But pull the 3 out, then the expression is 1 over x, right? 3 times 1 over x is the same as 3 divided by x. This allows me to recognize what the function part is, right? The function part is 1 over x. That's the part that I want to find the antiderivative of. What function gives me the derivative 1 over x? Right? 3 is just a constant that comes along. Now the family of antiderivatives. Well, the first rule is the exponential, which is itself 10e to the negative 0.2x. But remember, this is the derivative. I want to undo the derivative. Well, when I took the derivative, I would have multiplied by that number, negative 0.2. Well, I want to do the opposite here. I'm going to divide by that number, negative 0.2. Plus, not plus, minus. Alright, then 3 is just a constant. Negative 3 is just going to come along. Then it's the antiderivative of 1 over x. Remember, though, there's a special thing that you have to remember about the natural log. Remember, the natural log, you can't plug in negative numbers. The original expression could have had negative numbers. It can't have 0, but it could have original negative numbers. And so to get around that, you have to remember to put the absolute value. That means it works for all possible values of my original expression. Alright, so it's the absolute value of x that goes into my natural log. And then also don't forget the plus c. That gives me the family of antiderivatives. And so this is not how you should leave it. You should simplify. You have your calculator. You can take 10 divided by 0.2 or again multiply by a fifth. So I get negative 50e to the negative 0.2x minus 3 times the natural log of the absolute value of x plus c. And there is my antiderivative. If I take the derivative of this, it would give me my original expression back. It would give me that 10e to the negative 0.2x minus 3 times 1 over x plus c. Right, and it would. If you took the derivative of that, that's the expression that it would get. Now, again, that would be the check step. You can't do a mental check to make sure that's the case, but that would hold true. All right, the second example. All right, this one I have to rewrite a little bit. So I've got the square root of x cubed, 12 divided by, and again, students will get confused here because they'll try to do a natural log. You can't do a natural log. Natural log is only for 1 over x, not 1 over x cubed. 1 over x cubed, I rewrite. Alright, so my first step is to rewrite this. I have to rewrite this as a fractional power. And then I have to rewrite this as a negative power. Alright, so square root of x cubed is the same as the power 3 halves, right? The square root is a half. The cube comes along. Negative 12, and then I move that up and I get negative 12 times x raised to the negative 3, right? Negative 3. And then the rest of it's fine. Alright, those are the two things I have to do first. Alright, now I can use my rules. Just like the derivative, I have to do the same thing with the antiderivative before I get started. Alright, so the first rule though is my x raised to the 2/3 or 3 halves. Remember, I add 1 to that. So I'm going to add 2 over 2. So I'm going to get 5 halves. Now instead of dividing by 5 halves, which is an improper fraction, and if you write it divide by 5 halves, that's fine. But I like to go, well, I know if I divide, it's the same as multiply by the reciprocal, so I just go ahead and write times the reciprocal. I know I need to have the reciprocal up front in order for, when I take the derivative, it to cancel out the 5 halves. Alright, so I get 2/5 times x raised to the 5 halves minus 12, and again, negatives are always tricky. Right, if I'm going to mess something up, it's my negatives. Remember, I'm adding 1. Alright, we gotta get out of gear here. It's switching directions. And so it's negative 3 plus 1, so this is going to be a negative 2, and then I divide by that negative 2. Alright, x pi 5 plus 1 would give me 6, divide by 6, and then remember when it's just a constant, it's the constant times the variable. And then don't forget the plus c, so I make sure I find all possible antiderivative. And then we clean it up. 2/5 is fine, x raised to the 5 halves. My negative 12 divided by my negative 2 will give me a positive 6, x raised to the... And it's fine. I'm fine if you leave it raised to the negative 2. My lab might want you to divide by x squared. So again, depends on, if you're looking at my lab, they might want you to rewrite that as x. 6 divided by x squared. But again, I'm fine if you leave it fractions or negative. Same thing with the 5 halves. They might want you to rewrite that as the square root of x to the 5th. Again, I'm fine with fractional powers. Just make sure you be careful with the MyLab stuff. Alright, the next example, I have to do some simplification first. We actually don't have a quotient rule for antiderivatives. It doesn't exist. So either I have to, it's a special case where I can use a logarithm, or I have to manipulate the function to get rid of the quotient part, right? I have to move my fraction up and make it negative exponents, which is what we're going to do here. First thing I'm going to do is I'm going to split it into the two little fractions. Right? 5 divided by x to the 4th plus x squared divided by x to the 4th. And then rewrite it. I get 5x to the negative 4. Right. This would have simplified to x raised to the negative 2, right? When I divide, I subtract my powers, right? So it would be 2 minus 4, so x raised to the negative 2. dx. Now I can use my antiderivative rules, right? 5x to the negative 4. Now you gotta be careful, they're negative powers. So when I use my power rule, remember I'm adding 1. So x raised to the negative 3 divided by negative 3. X raised to the negative 1 divided by negative, right? I add 1. It's real hard. Again, where I mess up is negatives. You've got to make sure you're careful with your negative, and then don't forget your plus c at the end. And again, I'm going to clean this up. This would be negative 5/3 x raised to the negative 3 minus 1 x raised to the negative 1, or if I rewrite it without negatives. Again, I don't care if you leave negatives, but the book sometimes is a little picky about it. Alright, the last example. Alright, same thing. Right now we don't have a product rule. And we won't have a product rule that's a straightforward product rule. Now we will eventually get what's called the integration by parts, which is undoing a product rule. But that's at the very end of chapter 4. Alright, so right now we don't have it, which means we should be able to multiply it out to get rid of the product part. Right, there is no product rule right now. And there really technically isn't a product rule. There is an integration by parts, which has to do a little bit with the product rule. Which again, that's way at the end of chapter 4. Alright, so it's a product, right? I've got 12t squared times the 0.3t minus 0.2t squared. So again, there is no product rule, and so I have to undo the product. Well, undoing the product just means multiply those two expressions out. And so this means a distributive step. So 12 times 0.3 is going to give me 3.6 t to the 3rd, right? T squared plus t to the 1st gives me a cubed. 12 times 2.5 comes out 30. T to the 4th, right? T squared times t squared gives me t to the 4th, right? Now, there's no longer a product. It's just two little functions being subtracted, and I can use my power rule. Alright, so the antiderivative of this would be 3.6 comes along. It's t raised to the 4th divided by 4. 30 t raised to the 5th divided by 5 plus some constant. Clean that up. I'd always clean it up. Don't leave it in proper fractions or fractions you can reduce. Right, so the antiderivative would be 4 goes into 38, 3.6.9 t to the 4th minus 6x to the 5th plus some constant. There is my, oops, switch to an x there, t to the 5th, not x to the 5th. And there is my antiderivative for that function. So again, no quotient rule. There isn't any quotient rule. Doesn't exist. And technically there's no straightforward product rule either. We will eventually do integration by parts, which is kind of a product rule, but we don't have one right now. Same thing for the chain rule. We will eventually have a what's called integration by substitution, which is undoing the chain rule, but that again is not until the end of chapter 4. So right now we just have these basic rules. Alright, so antiderivatives right now are just simply basic power rule, constant rule, constant multiplication rule. Alright, so those are the ones you kind of need to do. Those are the ones we're going to apply in applications. Alright, we'll stop there, pick it up in the next video.